Hello, and welcome to Unit 6, Lecture B. We're going to talk about three major groups of elements on the periodic table today. So metals, nonmetals, and metalloids are going to be the three major groups. We'll talk about metals first because most of the elements on the periodic table are metals. There is a black stair-step line on your periodic table. Everything to the left of that line, with the exception of hydrogen, is a metal. Metals have some things in common. They all easily lose electrons. That is probably the key to being metallic. If you can very easily lose your electrons, you have low ionization energies, so it's very easy to remove your electron and you become a positive ion. That's generally the key to be considered metallic. All of the metallic elements are solids with the exception of mercury. You must memorize that mercury is a liquid at room temperature. Most of them are silver or gray. Most of them have a high amount of luster. Luster means how shiny they are. So metals conduct heat and electricity really well because of the movement of their electrons. They easily lose their electrons, which leaves behind kind of this positive nucleus, but then they gain electrons from the atoms right next to them. So constantly you have this flow and movement of electrons through your sample of metal. A lot of times they will refer to metals as being positive ions immersed in a sea of mobile electrons. Those mobile electrons move from atom to atom, pulling heat, pulling electricity with them, and they move so fast they're bouncing light off, which gives them their luster. They are malleable. Malleable means you're able to pound them into sheets. Instead of having bonds on a crystal pattern, where if you hit it with a hammer, it's going to break on that crystal pattern or shatter, what happens to the metals is they just stretch because they're sharing all of those electrons, and you're basically just kind of pulling the things apart, almost like silly putty. Ductile is very similar to malleable, except it specifically refers to being drawn out into wires. Remember that the most malleable and most ductile metal is gold. Gold has a high amount of malleability. The metal with the highest amount of luster typically is pure silver. We memorized that mercury is a liquid at room temperature, and metals get more metallic as we go down and to the left. So down and to the left on the table is going to give us lower and lower ionization energies. So if you're looking for a general trend, elements get more metallic as we go down and to the left. So let's take a look at where they are on the periodic table and some examples of what they look like. Okay, so the grays on this periodic table are your metals. So all of the ones that are in gray are metals. The cream-colored ones are nonmetals. The blue are going to be metalloids. And these two rows down here at the bottom, the white ones, lanthanids and actinids, they would be considered metals or metallic. A lot of them are radioactive. Pictures of metals: silver and tungsten, zinc, typically silver, shiny pieces of material. A few of them have colors to them in their pure form, like copper and gold, but for the most part it's just gray or silver. Malleable, pound them into sheets, pull them out into wires. The nonmetals are in the picture down here. They tend to be brittle. So that means, like these chunks of sulfur or these chunks of phosphorus, the red is phosphorus, the yellow is sulfur. If you hit them with a hammer, they're going to break and shatter into pieces. There is one liquid nonmetal, and that's this yellowish or this orangish brown liquid in the flask, and that's bromine. Metalloids fall in between metals and nonmetals. Boron and germanium are two examples of metalloids. They tend to still be silver and shiny, but instead of being malleable, they tend to be brittle. Where nonmetals are non-conductors and metals are good conductors, metalloids can be called semiconductors. They will conduct electricity, just not as well as metals do. So since their properties fall somewhere in the middle, They're the dividing line in the properties, and they get their own group called metalloids. You'll notice on here at the bottom, know that depending on your source, they may or may not include PO, polonium, and AT, astatine, as metalloids. Nonmetals, elements to the right side of the periodic table, they tend to be poor conductors. They tend to make negative ions. They gain electrons so that they can look like noble gases. Most of them are actually in the gas state. So you have all of the noble gases, oxygen and nitrogen, fluorine and chlorine, also gases. Bromine is the only liquid. So there's only 2 liquids at room temperature on your entire periodic table. Mercury is the liquid metal. Bromine is the liquid nonmetal. Make sure you memorize both of those 2. The rest of the nonmetals are solids. When they are solids, they are brittle. So that means if you hit them with a hammer, they're going to smash into pieces. Think of a charcoal briquette. They have low luster, so most of them aren't shiny at all. We say that they're dull instead of having luster. Nonmetals tend to have high electronegativities, except for the noble gases. The noble gases don't have any. Electronegativity is how well you attract electrons. So since nonmetals want to gain electrons to look like noble gases, they tend to have very high electronegativities. All electronegativities are based on fluorine having an electronegativity of 4. So they gave it the highest, 4.0. It gains electrons the best. Everything else is compared to that. The noble gases don't have any electronegativities. If you look on table S, you're going to have dashes and blanks here for the electronegativities of noble gases. They just don't have any at all. They do have ionization energies, though, and ionization energy is how much energy it takes to remove an electron, and noble gases have the highest, and nonmetals have very high ionization energies in general because they don't want to lose any of their electrons. They try to hold on to all of them that they can. Metalloids, again, somewhere in between metals and nonmetals. Their properties are going to vary. Some metalloids look more metallic, some look more non-metallic. Keep in mind that on this stair-step line, though, aluminum right here is definitely a metal. So on the stair-step line, metalloids, with the exception of aluminum, he definitely has 2 metallic of properties to be considered a metalloid. Probably the most important one for us right now would be silicon because of computer chips and using it for that. It's because it's a semiconductor, so it conducts the electrons slow enough for us to use it for binary code for a computer. Boron becomes a really great disinfectant. It's used in rocket fuels. It's used in all kinds of industrial purposes. Arsenic is a poison. That's AS. Not allowed in rat poison anymore because it was too easy to hide it. Tastes like bitter almonds, so it was too easy to hide it in foods that took out of rat poison. And again, polonium and astatine, radioactive, so may or may not be considered metalloids. Those are the 3 major groups. Know their basic properties.